Next, a very simple thing, potential due to a charged shell of radius r. See, this is a shell of radius r. Then, shall I give charges to it? The charges reside on surface. You know. Then, I am considering a point here. This is a point outside at a distance r from the center. Okay, the net charge given is capital Q, suppose. So, what is the total charge given? Q. So, what is the distance to the point? Small r. See, what is the potential at this point? Potential at that point is equal to, potential is equal to 1 by 4 pi epsilon 0 Q by small r. Keep in mind, what is the potential at the point P? 1 by 4 pi epsilon 0 Q by small r. Q is the total charge given to the shell. Okay, then small r is the distance to the point. This equation is similar to what? The potential due to a single charge. Okay, see, this is a charged shell. What is the radius of the shell? Capital R. So, charges reside on the surface. What is the total charge given? Capital Q. So, we consider a point P outside. What is the distance to the point? Small r. What is the potential here? 1 by 4 pi epsilon 0 Q by small r. So, very clear, potential is inversely proportional to r. Am I right? Then, next is potential on the surface. Now, you consider your point here. See, the point P is here. If your point P is here, the distance small r becomes equal to capital R. Am I right? Then, what is the potential here? Tell me. Potential is equal to equation 1 by 4 pi epsilon 0 Q by capital R. Because the distance small r here becomes capital R. So, what is the potential on the surface of the shell? 1 by 4 pi epsilon 0. Vinayak, what is the potential on the surface? 1 by 4 pi epsilon 0 Q by capital R. Okay. Then, what is the potential in the interior? You take a point in the interior. If your point P is in the interior, see, potential is, see, always keep in mind, potential at any point in the interior has the same value on surface. Keep in mind, potential at any point in the interior has same value as on surface. So, what is the potential? 1 by 4 pi epsilon 0 Q by capital R. So, keep in mind, what is the potential outside? 1 by 4 pi epsilon 0 Q by small r. What is the potential on the surface? 1 by 4 pi epsilon 0 Q by capital R. So, what is the potential at any point in the interior? Potential at any point in the interior has same value as on surface. What is the answer? 1 by 4 pi epsilon 0 Q by capital R. See, I am plotting a graph here. See, this is small r, this is potential. Okay, V versus R graph I am plotting in this case. See, this is the center O, then this represents R, means center to surface. So, this region represents center to surface. Potential has same value, am I right? So, this is center. What is the potential here? 1 by 4 pi epsilon 0 Q by capital R. What is the potential on the surface? 1 by 4 pi epsilon 0 Q by capital R. See, from center to surface, the potential has the same value. So, potential is a constant. Am I right? Up to this, the potential is a constant. So, it is represented by this horizontal line. Then, after that, for a point outside, potential is inversely proportional to R. So, the graph will be like this. So, this outside, then this inside. Okay, inside from center to surface, potential is a constant. Outside, potential is inversely proportional to R. So, this is a very important graph, keep in mind. Okay, so what is the potential outside? 1 by 4 pi epsilon 0 Q by small r. On the surface and in the interior, 1 by 4 pi epsilon 0 Q by capital R. Okay.